So here I've got my handy dandy candy thermometer, 4 tablespoons of cornmeal, 4 tablespoons of sugar, 4 tablespoons of salt, 2 cups of water, and my pan. I'm going to pour the 2 cups of water into the pan and then turn on the gas to a medium-high heat, and I'm going to bring that water up to a boil. I'm using my candy thermometer to take the temperature of the water because it can reach higher temperatures than my digital thermometer can. So now that the water's come to a boil, I'm going to take 1 tablespoon of the kosher coarse salt that I've got, and I'm going to add it to the water. I'm going to mix this up with a heat-safe spoon to make it into a solution, and we'll monitor the temperature accordingly. Alright, I am now adding the 2nd tablespoon of salt to the salt water solution and mixing it up to form another homogeneous mixture. I noted that after adding the 1st tablespoon of salt to the water, it reached a rapid boil at a second time, or at about 216 degrees Fahrenheit, so the boiling point did increase. And I didn't get a video of me adding the 3rd tablespoon of salt into the water, but this is a video of me mixing it. After adding the 2nd tablespoon, the boiling point rate rose again, and this time it reached 218 degrees Fahrenheit. Alright, and I have now added the 4th and final tablespoon of the salt to the water, and I'm going to mix that up. The 3rd tablespoon of salt raised the boiling point to about 222 degrees Fahrenheit. This final addition of salt to the water, bringing it up to 4 tablespoons, raised the boiling point to 226 degrees Fahrenheit. Alright, now I'm going to move on to the sugar. So I've got my boiling water, I've got my 1st tablespoon of sugar. I'm going to add that to the boiling water and mix it up, same process as I did with the salt. Right, we're going to record the temperature. Alright, after mixing for a little bit, I noted that the temperature only rose a tiny bit, and it rose to 213 degrees Fahrenheit. Alright, now I'm going to add the 2nd tablespoon of sugar to the boiling water. I'm going to mix it up and then record the temperature once it reaches a full rolling boil again. Right, after the 2nd tablespoon of sugar was added, the temperature rose up to 215 degrees Fahrenheit. Alright, I'm going to add the 3rd tablespoon of sugar now, and I'm going to mix that in. And after mixing it, I noted that the temperature rose up 1 more degree to 216 degrees Fahrenheit. Alright, I'm going to take the last tablespoon of sugar and I'm going to add that to the pot of boiling water, and then I will record the temperature after it dissolves and comes back up to a boil. Alright, and after mixing and tracking the temperature, I noticed that the temperature really didn't rise much more after 216 degrees. So overall, with 4 tablespoons of sugar added, the water only increased the boiling point by 4 degrees. Alright, we are finally going to move on to our final variable, which is cornmeal. Cornmeal is not water soluble the way that sugar and salt are, so my inclination, or what I can assume from that, is that there's not going to be much temperature change in regards to the boiling point of the water. The cornmeal will certainly absorb some of the water and will eventually come together into this thick substance very similar to grits. But it's not really going to have an effect on the vapor pressure of the water because it's not going to dissolve into the water, and because of that it's not going to have an effect on the boiling point. So this is just me adding the cornmeal into the water and noting that the temperature is not really changing, and it's just going to make my thermometer kind of messy, but it's okay because we're here for the learning. Alright, so now we're going to move on to the second part of the lab for today, which involves baking cookies on different types of material and seeing how that affects the bake of the cookies. So right now I'm just weighing out the 6 balls of cookie dough that I've got to make sure that they are all the same size and they all are ranging between 50. Now that the dough is all rolled out, I've got it separated by the 3 types of pans that we're going to use. So I've got a glass pan, a shiny metal pan, and then a darker, duller cookie pan. Alright, and this is just some extra footage that I've got, but basically what we are trying to figure out is how the different types of pans affect the baking result on the cookies. And pretty much what I have learned is that the darker pans without shine on them tend to absorb more of the heat from the oven, so the cookies are more well done, even when they're cooked at the same temperature and same amount of time as other cookies. The glass pan, because it is the least dark, and I'm guessing glass is a reflective material, because of that, the cookies were the least cooked, the most raw compared to the other 2 baking pans. So yeah, to wrap this up, I got 3 sets of cookies, and they all cooked a little bit differently depending on what they were cooked in. The glass pan, as you can see, well, the cookie just didn't really make it. It was pretty raw, it was pretty soft compared to the other 2. Yeah, it just kind of fell apart. The cookies that were baked on the darker, dull pan were the most well done. They held their shape, they were brown on the bottom, they were cooked through, they didn't fall apart when I picked them up, and they were pretty good. The shiny pan did bake the cookies, but they were much softer. If you look at the bottom of them, it is browned, just like the other one, but it has some spots where it's less cooked. It's a little bit more raw in the middle. This is kind of how I prefer cookies. I like them really soft, but the glass pan, it was not it. They would have needed to stay in there for at least 3 or 4 more minutes. Like, it's falling apart on the cooling rack.